like I said, my name's Zach Hanley, filling in for James, who just had a baby over the weekend. And I'm accompanied by Scott, another engineer on our team. Scott, you want to give a quick intro?
Sure. My name is Scott Friedman. I'm one of the sales engineers here at H3. I'm based in Dallas, Texas, and I've been here. Actually, I'm at my year right now. So, all right. So I'm looking forward to answering. I'll be monitoring the chat. So we've got the chat here. If you want to send questions to just the panelists here, but we've also got the Q&A. So if you've actually got questions while we're going through the content, ask it in the Q&A, and I'll answer some in the Q&A pod, and then some we'll probably answer live in the presentation.
Yeah, definitely ask questions as we go. I'm a active learner. I'm sure a lot of you guys are too. So stop me in my tracks if I say something that doesn't make sense, or if you just want to give any more good tips that I'm going over at the time. All right, so we're covering how an attack team hunts new exploits. I'll give a quick who am I. I went to University of Delaware, Georgia Tech, also prior military, worked within a small unit within JSOC, supporting different intelligence activities through cyber means. And then after I got out, I went to work with a government contractor doing similar work, doing implant development and vulnerability research. And that's actually where I met James too. Now I'm a vulnerability researcher and attack engineer at Horizon 3, and I am a husband and father of 2 boys. And that's a picture of my wife and my 2 boys down there. So what are emerging threats? So on the attack team, what we do is we have this emerging threats lifecycle. And when we say threats, what we're really talking about are what are the emerging vulnerabilities within the cybersecurity space today. We're not talking about what are different type of malware families that are being discovered. We're really focusing on vectors that a threat actor can use to breach your network. So why would I want to keep up with emerging threats, and why would I want to practice this emerging threats lifecycle? So for defenders or the blue team, it's really you want to beat the breach. And for the red teamers or penetration testers, you want to be the breach. So what are the 4 parts of this emerging threats lifecycle that we follow to rapidly discover new vulnerabilities and exploit them? One, it's threat intelligence. We have to keep our feelers out there, seeing what new advisories come out day to day. We're on Twitter, things like that, looking for new end days and 0 days. Then we're triaging all the threats that we find. Are these actually going to be impactful for people around the world? Is it going to lead to initial access? Is it going to lead to privilege escalation, compromising a domain? And then rapid reversing and exploitation. So it's obtaining a test article, finding the software from the vendor, looking for it wherever you can get it. And actually, we're going to look at and do a case study on the recent Veeam backup and replication vulnerability that came out about a month or so ago now. And then the last phase of this life cycle is actually integrating it into our engagements and our products. So being able to actually assess if a client is vulnerable to it, and then also releasing that proof of concept out into the wild. We'll post it on GitHub so that the rest of the information security at large can use our research. So how do we find vulnerabilities to actually go after in this life cycle? So one of the things that is lacking right now is a lot of vulnerability databases like the NVD lag behind on critical vulnerabilities from days to weeks. So you really have to go out there and find your own sources. So almost every single morning, I'm out there looking at vendor security pages. And so I'll pop open VMware, Fortinet, Sophos, you name it. If it's a big enterprise security vendor, we're out there looking at those advisories every single day to see if anything new has come out. Social media, Twitter and Reddit, like Reddit NetSec, are some of the best ways I've found to discover when something is popping off in the industry. And then patch investigations. Sometimes a vendor, I'll name drop one, QNAP, they are the worst at actually disclosing when they patch vulnerabilities. They don't release a CVE ID. They don't say anything about it. That screenshot right there is applied multiple security updates to further enhance security, system security. That's the most vague thing in the world. How you know if it's something critical you should actually patch. So In these cases, we're actually popping open these patches and seeing what they fixed to assess, hey, is this something that's really impactful that we should be getting after? And then the last place where we're looking at is we conduct our own zero-day research for popular enterprise applications. And when we do that, we follow the responsible disclosure policies and coordinate with them. So once we find something that we think is interesting, now we have to triage it. And what are the big factors that we look at when deciding if we should actually go and start reversing an application? It's looking at the CVSS score, but the CVSS score isn't always the ground truth. Commonly, you'll find that maybe the score was not applied properly, and so it might be ranked at a high instead of a critical. And then product popularity. Is this a huge enterprise application, or is this like some one-off application that's only going to really affect maybe a dozen people out there? And then also there's the wow factor and research interest. We're also trying to expand our own skill sets and going after things that maybe haven't been looked at before. So after we found something that we think is interesting enough, now we actually have to go out and find it. Then we have to deploy it. We have to identify the key pieces of that software, of where that vulnerability may lie, and we have to actually open that up and start researching. So downloading software is actually becoming one of the hardest parts of this entire cycle. You would think that at the actual vulnerability research side is the more challenging part, but actually obtaining software is becoming increasingly difficult because vendors are putting software behind their paywalls. You might need a freemium type account to sign up and download their updates. You might actually have to be fully licensed and a customer to download that specific application. And so what this means is that we have to go out there and we're searching on really shady sites, trying to obtain the software to do these patch diffings. And if we can even find multiple versions, we might just be going in blind with a single version. So after we get it, we deploy it, we're looking at the configuration. A lot of times, like I said, it's becoming more difficult. Once you actually deploy it, is the vulnerability in the default configuration of the device. So here you actually have to look at the vendor advisory a lot of times and read it really carefully. And sometimes they'll disclose the component that the vulnerability lies in. It gives you a really good hint of where to start looking. Identifying key pieces. When you install this software, what binaries land on your operating system? What configuration files are there? What logs are there? You want to find this out because one, you need to be able to find the binary to actually start conducting the research, but then also knowing where the configuration files and log files are really important for when you start doing dynamic analysis. So say you've done a little bit of static analysis after you've opened up the binary in Ghidra or IDA, and you want to test out a hypothesis. You want to be able to look at those logs while you're interacting with the application in real time to see if you're actually reaching down into the code paths that you think you are. So yeah, identifying key pieces, and then the vulnerability research. This is sometimes the short part of it, and sometimes it's the long part of it. It really just depends on that vulnerability. So targeted vulnerability research. Once you actually get there, we're opening up the binaries in Ghidra, IDA. A lot of times what we're going after are these enterprise applications that are firmware images, whether they're KVMs or things like that. We can pop them open in VMware and start running them ourselves. Sometimes you have to build your own custom tools. And that can add a lot of time to the cycles because you're basically having to iterate and find different ways to interact and reverse an application. And previous research, typically I would say that a lot of things we're looking at, the exact same vulnerability doesn't exist across different vendors, but there does seem to be a rhythm to it. So earlier this year, there was several issues surrounding unpacking archives securely, where The vulnerability was you could upload a package and then the system would unpack the archive, but it didn't do it in a secure manner. So there seems to be a rhythm to it. We just got a question in. It says, when does Horizon 3 decide to add a vulnerability to NodeZero? So usually we're going after the truly critical and exploitable vulnerabilities that affect large swaths of customers. So similar in the way that I said, where how we qualify what's a vulnerability to go after in terms of weaponizing for the vulnerability research standpoint, the same thing is true when a proof of concept may already exist. So, I mean, information security has been a field for a long time. So we're not the first ones in this industry. And we also take other contributions from the industry where if they've already released a POC for a vulnerability, we're taking that, we're trying to harden it, things like that. So basically, to answer your question in short, it's if a vulnerability can be exploited and you can derive a critical impact from it, or it can be used in a chain of attacks, then we're looking definitely at adding that.
That's a great question, by the way. I appreciate. I was going to jump in and say I appreciate the question from Anthony, mostly because Anthony's a customer of mine. So it's been it was good to I saw him join here and then ask the question. So appreciate that, Anthony.
And then lastly, here is collaboration. Vulnerability research can be lonely, and you might drive yourself mad a lot of times. Just you get stuck on some little thing. But then when you have great teammates, or you ask somebody in the community just at large, like, hey, like I'm running up against this issue, a great team really accelerates research. So that's the last thing I'll say on that. So after we've actually done the research, we've created a proof of concept. We're actually going into the productization of a vulnerability. What does that mean? We're releasing that research back to the community. So you can look on our GitHub, you can look at our blogs. We release all those back to the community. And then we also integrate it into our products so that our clients can assess themselves and their own clients to see if they're impacted by this vulnerability and what type of attack paths can be derived from it. So to make this all a lot more concrete, we'll walk through the recent Veeam example. I think there might be a fight on how you actually pronounce Veeam. I don't know if it's VM, I've been told, but it reads like Veeam, so I'm not sure. So back in March, just last month, Veeam released their security advisory for this specific CVE. And just 2 days later, we see another security vendor release, they tweeted a picture of them weaponizing the CVE, but they did not release the proof of concept. And what it looked like was that they used a Windows executable to dump clear text credentials. So right off the bat, that piqued our interest. And then that following week, we see two more additions to the intelligence that have been released. So we see Huntress Labs releases a blog with an additional RCE vector where it's not just dumping credentials, you can actually obtain remote code execution. And then shortly after that, we see the Twitter user, I don't know how you say his name, but Yasser Chabug released his technical blog. And so if we look at the advisory down there in that picture, we see that it says it allows unauthenticated user in the network to obtain encrypted credentials. So that's I would say a very poor description of the vulnerability by the vendor, because it actually allows dumping clear text credentials as well as leading to remote code execution. And what's probably the most strange in all of this is that the CVSS score was ranked at a 7.5, putting this at a high. So depending on what type of vulnerability management processes you have, guess what? This is probably going to fall down to things that are not an immediate fix because it's a high. I think a lot of people have processes where if they're critical, they're addressed immediately or in some time frame. But because this is a high, I think this is actually advantageous to an attacker, because now a lot of organizations are not prioritizing this fix. So from an attacker's point of view, this is a really good bug to get after, to try to weaponize and to use to breach organizations. Okay, so carrying on with what I said is Veeam, it's common enterprise application. From a lot of my experience in assessing clients and engagements, I know Veeam is really widely used. It leads to credential dumping, remote code execution, well-documented root cause from other security researchers in the community, improperly assigned CVSS rank, no public exploit so far. Excuse me. And all the private POCs that we saw proof of were all based on Windows executables. So that was a little interesting to us. Like, we didn't really understand why people weren't creating like Python scripts or anything that could be ran on Linux just yet. So we decided to get after this one. So the first part in our list that we covered in this emerging threat lifecycle is now we need to obtain the actual software. So when Horstman and I were getting after this one, we were reading through the blogs and we were trying to find he was trying to find the software. And I was actually on a flight over to California when this was popping off. And I pulled out my laptop on the plane, and it turns out that for some reason I just had a few copies of old Veeam from the past couple of years. And the joke down there was he asked me, do I just download Veeam in my free time? And I said, I have a sickness. So luckily we had it. The next step is actually deploying it. Deploying software is actually sometimes really painful in this process, especially Oracle. I don't know if anybody has ever tried to deploy Oracle applications, but it takes reading through hundreds of pages of documents and just days to deploy it. And if you can even get it deployed. But luckily here, it was easy as just dropping the ISO in, starting the VM, and it just deployed. So it was easy. So now we're into the reversing part. This vulnerability had already been covered by other security researchers in the community. So we had a pretty good head start on where to look and where to start actually trying to reverse. So starting there, we knew it was hosted on port 9401, and looking at the type of implementations in their source code. When we popped it open, we could tell that it was a Windows Communication Foundation service, commonly said as WCF. And what that means is it's a messaging protocol built on top of TCP, but it's not HTTP. It's a binary marshaled protocol. So that restricts us to implementing the POC in a .NET language, because that's the native language to implement Windows Communication Foundation services. So at this point, we know we need to create a client that can communicate with the service. But what we didn't know, and what we were wondering about from the other security researchers community, is why were they using Windows executables, and why weren't these implemented in Linux POCs? So we were wondering, how can we re-implement the Veeam stubs? And what I mean by stubs is commonly when a vendor creates an application, they have these shared libraries that they use to create all their functions, their custom functions. And so what we had to do was look at their custom functions within their libraries and see what were the minimum set of functions we had to re-implement to not have to depend on them. So iterating in this stage is super important. Iterating quickly is super important, because the quicker you can get to a success or a failure, you learn something, and you have to then just iterate again and again until you actually get to a point where you can actually communicate with this service. And for all those people who want to know a lot more details about the actual reversing process, we have a blog out there on our site that'll go in a lot more detail than I'll cover in the next 5 minutes. So we had a basic client written where we could communicate with the service. Now we actually had to re-implement those functions I was talking about. So in this case, we're re-implementing the get cred function. And probably the most difficult part about this was Veeam had a custom binary marshaller for the data. And so we had to find a way to unmarshal the data without depending on their library. And the funny thing about it is that James found a way to do it by referencing a 10-year-old Stack Overflow question about doing something very similar. And so Stack Overflow, it's a researcher and a developer's best friend. So if you're stuck, I'm sure there's an answer somewhere on Stack Overflow. So as you can see on the right, we have a picture of us executing the proof of concept, and we dumped the clear text super secret password. So we've got the POC. Now we're to the stage where we want to release it to the community. We want to integrate it into our product, and we want to assess the impact to our clients. So I pulled some stats over the last month since this has been released, and it's been exploited in 29 engagements. 124 clear text credentials were dumped. Of those credentials, 20 of them were domain administrators off the bat. 31 of them were domain users, and a lot of those domain users were overprivileged. One of those credentials was a full AWS org admin. 4 of them were regular AWS users with also elevated permissions because they were doing a lot of backups. So they had read access to a lot of things, even though they weren't admin, they had access to a lot. Local admin includes both Windows local administrators as well as users like root on Linux boxes, and there were 39 of them. And then I think really interestingly, there was 8 vCenter admins. So these credentials led to admin access on their vCenter clusters, which deployed tons and tons of VMs throughout their enterprises. And if you look at the top right, the occurrences over time, it's actually kind of interesting. I would have expected that we would have found a lot up front, and then it would have kind of tailed off at the end here. But starting in March, we see 1 or 2 every day, and it's just been constant ever since. So I think that goes back to show that how the CVSS score was, I would say, improperly ranked at a high. And I think that shows here because organizations still are having this found in their environments. And then next, we're going to walk through some really interesting paths that we found by exploiting this vulnerability. So the first one was a pretty simple one. We exploited Veeam, and we dumped a AWS key. That AWS key ended up being a org admin in their AWS account, and it also was a cross-tenant org admin, so it had access to other tenants. The next path that we found that I thought was pretty interesting was we dumped a regular domain user from Veeam, and then that domain user was a local admin on an endpoint. And we used that local administrator permission to dump SAM on that endpoint. And so we got the local administrator accounts NTLM hash. And we then took that local administrator's NTLM hash and tried it as on the domain. And the domain administrator had the exact same password set. So it was password reuse that basically brought them down. And then the last path that I'll cover is it's pretty wild. It's actually not too wild, but it's pretty crazy that the product found this. So we exploited Veeam and dumped a regular domain user. With that domain user, we enumerated all the users in the domain. And then we password sprayed all those users we just found with the same password as that domain user we got from Veeam. And the domain admin, a domain admin had that same password. And so we compromised the NodeZero product compromised the domain by just reusing that password. So that's all I've got for you guys. I'm hoping you guys have any questions. It's not limited to just this Veeam one. If you guys have questions about the methodology, specific other vulnerabilities we've covered, I'm down to cover anything.
No questions, man. We got 40 people in here. Well, some of our folks, but hopefully some folks have questions or anything. We could potentially even go into a demo. We could show a little bit off. Zach, we could do a little Cypher preview. I'm sure a lot of people on this call might not have seen our new interface.
Yeah, so the attack paths that I showed you here are all things native to the new interface of our product, so that when an operation or engagement is kicked off and we find something, it'll actually show you the exact paths that were taken to exploit issues and reach impacts. Oh, we got a question in. It says, do you have other recommendations for people you recommend following on Twitter or other feeds you recommend we follow? So I like to use Twitter really in for threat intelligence. So I would say that almost every single person I follow maybe like 300 people on Twitter. They're all really high quality security researchers or people in the information security community that are contributing to tools. So I would honestly just go to my Twitter and just like try to just start following all the people I follow, because I don't follow it really for any personal reasons. It's all just for threat intelligence. So I'll post my Twitter handle in here. It's @HacksZach. Oh, I gotta send it to everybody.
One thing I'm pretty religious about watching is I watch the Security Now podcast on the Twit network. I don't know if anybody here watches, does podcasts, watches some of those. But I like the ones on Twit, which I'm an old school guy. It goes back to Tech TV days. If anybody remember Tech TV we had on cable. And it's a lot of the same folks that were on that, and they do a bunch of podcasts. So anyways, the Security Now one, it's a weekly podcast, and they talk about a lot of different subjects and topics, and super educational about different types of exploits and different types of new vulnerabilities that are coming down. Things about malware, ransomware, etc. Yeah, go ahead.
Yeah, I was going to say the other tools I use for intelligence it's kind of plugged on top of Twitter, but it's called cvetrends.com. And basically that site crawls social media. And if there is a CVE that's picking up like trending, it will highlight how trending it is. And so you can see like the top 10 vulnerabilities today or this past week that are trending on social media. And typically those are really insightful, because they might be just being announced, or they might be something that you missed from a few days ago. So cvetrends.com is a really good one. We have another question. It says, I wanted to know if you are also focused on exploit in K8s environments and serverless environments. So yes, we have quite a bit of attack content focusing on both K8s and Docker deployments. So if we discover some of the K8s APIs or Docker APIs or anything like that open on a host, we'll start enumerating and we'll start looking for a lot of common misconfigurations. And based on the type of misconfigurations, we might try to execute code inside a cluster or a pod and see how far we can actually take it in those types of environments. there's another question: is GPT helping your speed yet? I would say yes. I think James, I've noticed James actually used ChatGPT a whole lot. Back when I said iterating fast is key to success, one of the key areas we've both seen in using ChatGPT is trying to iterate faster. So when you're trying to implement a POC or write a simple piece of code in a language you've never written before, like this Veeam one was in .NET. So I don't commonly write .NET, and neither does James. And I think it came in really handy to be able to ask ChatGPT, hey, can you help me write a client to do this thing? And that's a really common pattern. Just like asking ChatGPT to do these small things that you can build on and refine. Like ChatGPT isn't going to be right about everything, but it gets you a really good starting point where it really speeds up your time. So I would say yes. What about you, Scott? Are you using ChatGPT?
Not so much just yet. But we did a session a few months ago where a bunch of us got together and we were kind of feeding it different things and sort of trying to understand how we could use it. It's kind of interesting. There's part of our new interface is we have spots where we give narratives on particular exploits. So a customer can sort of understand what this vulnerability is and what the potential impact could be. And some of it is it's good if we feed data through ChatGPT for that, because it gives like good descriptions of like, if you said, hey, tell me what eternal blue is and how it could infect my network, it'll give you a really good description, helping you really educate yourself on what these particular exploits are.
Another funny use case of ChatGPT that we were testing out was James and I competed in Pawn to Own, which is a hacking contest that's hosted a couple times a year. And in that contest, we found a 0 day on a printer, and it was a really easy vulnerability that we were kind of surprised that was discovered and or not discovered before us. And so we tried using some off-the-shelf application security tools to see if it would identify the vulnerability without any like humans being involved. And surprisingly, it didn't find it either. And so then we tossed in the vulnerable whole file. It was a bash file of all things. We tossed it to ChatGPT, and it did identify there was a vulnerability, a command injection vulnerability in this file. And it was pretty surprising that the actual tools that are out there didn't find it, and ChatGPT kind of did. Whether it actually knew it was like how to exploit it or not, it did find it. So I thought it was interesting.
Funny, because one of the exploits that we look for is that anonymous printer access one, and I've even wondered, like, what kind of things could you do with a printer? But if you think about it, a printer, I mean, it's running an operating system. It's a little system, so I guess you could take it and maybe start using it as a as a launch point for potentially other things. A lot of people don't think about all these different devices on our networks and how they could be turned into a launch point for a piece of malware, piece of ransomware, or something like that.
Right. Yeah, it's also stores possibly service credentials for your environment, and also who knows what you're printing, you could get all that stuff too. So
yeah,
that's all we've got. If there's no more questions,
yeah,
I don't think we're going to take up your time with any more stuff. I don't think we'll do a demo. We don't have that much time. So if anybody has any more questions that they didn't want to ask here, they think of later, don't hesitate to reach out to myself or Scott or somebody here at the team. And thank you guys for being here.
My email is scott@horizon3.ai. Zach, I think you've probably got a similar email.
Yeah,
so
mine is Zach, ZACH @horizon3.ai. So any questions, just hit me up.
So if folks want to, if you'd like a demo, like a product overview, or you have some questions, if you're an existing customer or a prospect, yeah, feel free to reach out to us, and we'll be happy to assist you. So we appreciate everybody's time and going through this, and we appreciate Zach with the amazing content as always.
Introducing NodeZero from Horizon3.ai. NodeZero is autonomous pen testing as a service that acts as your Purple Team partner. You get results in hours or days, not weeks or months. Don't spend time chasing down false positives. NodeZero goes beyond finding weaknesses to identify what can be exploited within the infrastructure. Then verify. Immediately rerun on demand with just a few clicks, and go through the find, fix, and verify loop to confirm that you've successfully addressed what matters.